Olfaction is what? Smell. Taste, vision, hearing, and balance. Okay, we've kind of alluded to some of those things along the way. Olfaction, sense of smell. We have what's called the olfactory epithelium. That's the tissue that we had discussed when we were talking about cells back in the first part of this semester. Superior portion of the nasal cavity, the olfactory region, when you're up there digging for gold, you know, you got finger up there and digging, you're right up near the superior surface of the nasal cavity. It is said that that entire surface is probably less than the size of a postage stamp. If you took a postage stamp, their standard postage stamp, cut it in half of it on each side, that is our olfactory receptor area, that region. So it says we have about 10 million neurons in that small space there, so they must be really packed in there. All right, so we have olfactory hairs or cilia, and they're going to be part of, and they're going to be embedded in mucus. Anybody remember about mucus? Mucus for what purpose?
Protection.
Lubrication and or protection, okay? So in this case here, we have these olfactory hairs, or cilia of the olfactory neurons, and are embedded in some mucus, so there must be some significance associated with that. We are going to make reference to things that you can smell that are called odorants. Odorants are dissolved in the mucus. So in most cases, they have to have a wetting agent for them in the mucus here. The odorants attach to the receptors, the cilia depolarize. We're going to have some action potentials. Here we go again. Those action potentials are necessary in order to get a threshold level here, and then we can have some, we have to have the depolarization here, which means that we have reached threshold level to initiate an action potential in these olfactory neurons. We're talking about receptors capable of sensing the environment, may respond to more than one type of odor. And the epithelium is going to be replaced as it wears down. Notice this, neurons are replaced by the basal cells about every 2 months. So if you end up having some type of a episode that takes place where as a result of something which you, an odorant that you inhaled there caused some damage to those, apparently we have the capability of having a new layer of those that are replacing them. All right, so this is what that looks like. We looked at this back when we were talking about the cranial nerves there. Here's the superior portion of the nasal cavity. Here's our olfactory bulb. These are these cilia that are passing down into the superior area of that nasal cavity. We talked about the concha. We made reference superior, middle, and inferior nasal concha. Remember, those are going to allow for some additional surface area, so that we're going to do 3 things in that area there. We're going to warm, we're going to moisten, and we're going to filter the air that's moving in there. And that's going to be really important. Those 3 things, you need to remember those. What's going to happen when you move the air in there? 3 things. You're going to warm the air.
Filter.
What is it? Moisten, and you're going to filter the air there as it comes in. Well, this is that, remember when we talked about some of those bipolar neurons that are going to be associated with, they're going to be very unique to the eyes and to the nasal area here. All right, so here we get into that discussion of how this is communicated here. And we talked about that G protein association we have here, binding of the odorant to the receptor molecules activates this G protein. So here's the odorant contacts here. Then we have this G protein, and we're going to have the adylate cyclase. Remember that adylate cyclase is associated with the transfer of ATP to cyclic AMP. Gave you that way back in the beginning of the semester, and it says, don't forget that one. Okay, here it is again. And that's going to make it possible for us. This odorant is going to open the ion channels here in this G protein mechanism. Activates the adylate cyclase. Adylate cyclase is an enzyme. Catalyzes the formation of cyclic AMP from the ATP. Here's our adenosine triphosphate, and we're going to have that adylate cyclase. Causes the channels to open, the ions into the olfactory hair, results in a depolarization. That's what we're looking for here. And then as a result of that, we're going to have the action potential in that olfactory neuron capable then of sending a message. Going to move along through here. I have an interesting, just anecdotal piece, not a testable piece, but how about this? You can detect about 4,000 different smells. There are professional people who are professional sniffers. They get hired because they have a particular sensitive capability. I met a fella a couple of summers ago, and he worked for a company, and his specialty was his hearing ability. And he was hired for his ability to be able to discreetly discriminate various different levels of sounds and variations of sounds. He worked for a large, one of these companies that develops these large amplification systems for stage productions. And his specialty was the idea that, you know, he had that tweaking sound capability there. So he was very careful with his hearing. Well, here you have people can detect about 4,000 different. Threshold for detecting odor is very low, and adaptation occurs quickly. Does this make any sense at all? A threshold for detecting an odor is very low, and an adaptation occurs quickly. Meaning what? That make any sense, that sentence there? Tess, you were going to add something?
I was going to say that it doesn't take much for you to be able to smell it, but you're able to, adaptation, like you're not going to smell it for long. You'll get used to it.
Yeah, it becomes part of the ambient air after a while, right? The kind of, I mean, it has to be fairly noxious, a fairly offensive odor for some of us to be intolerant of it. You know, in some of our workplaces, you are subjected to that same odor over and over and over again. Classic example I always consider is the one where we talk about nursing homes. Does anybody have a particular fragrance that they associate with nursing homes?
I know there's an old people smell.
It's what?
There's an old people smell, but I don't remember.
An old people smell. Is there a particular odor that's associated with nursing homes?
Urine.
What?
Urine.
Did you? I heard three people kind of say it at the same time. Urine. Isn't that interesting? Because when someone says nursing home, to me, the first long-term memory thing that comes up in my mind is smell of urine. When I was working as an ambulance, when I was working on an ambulance service there, whenever there were, I think there were 6, maybe 7 different nursing homes we went into, there was only one of them that you'd walk into and it said, oh, this is really nice. It's just pristine. All the rest of them, the first thing that hit you when you walked into the door was that smell of, it was just a foul urine odor. So if you work there, you either smell it all the time or you have adapted to not smelling it. Do you follow what I'm talking about? It's that type of thing. Maybe it's a survival skill if you work there. You can't keep sanitized all the time as much as you'd like to, or maybe you can. Replaced every 2 months from the basal cells and olfactory epithelium. Talk about, how about these? Primary classes of odors. Can you relate to any of these? Camphor. Mothball odor? Anybody use mothballs anymore? Did you ever smell mothballs? Got to bring some in sometimes. Say, here's what mothball smells like. Musky? What is that? That's a fish, isn't it? Floral? Man, there's so many different floral odors that are a variety of, you have roses, or you have something, maybe it's a honeysuckle or something like that. Pepperminty? Okay. Fresh pears, an ethereal. These are kind of odd names for some, a musky or ethereal. Pungent. Well, that's very pungent. What the heck is that? Putrid. Okay, so these are said to be the primary classes of odors. You won't be tested on those, but there's some interesting terms here that don't seem to register for most of us when we say, well, that's really a putrid odor. Okay, help me out. Meaning what? Nasty. Yeah, there's the word. You could have just put one more classification of class of odors there. Nasty. Right? Just put one more down there. It's nasty. Or the other one, it's good. Good and nasty. Those are our extremes. It smells good or it smells nasty. What do we have on the TV almost every night? It says, oh, you got to hold that clothing up to your face right here because it smells so outdoor fresh. What is outdoor fresh odor? Depends upon where you live. You live in downtown New York, outdoor fresh smells like the butt end of a bus passing by you, you know? You live in some dairy farm area, outdoor fresh smells like they just cleaned out the barn. Neuronal pathways for olfaction. You're going to have the olfactory bulb, goes to the olfactory tract, and then it's going to synapse with those association neurons. Receive the inputs here, so we're going to, oops, wrong one. Information goes to the olfactory cortex. Where's that going to be here? Of the frontal lobe. The olfactory cortex is without going through the thalamus. How about that? Remember we talked about all of your sensory input except, there was an exception there, right? Goes through the thalamus. It gets screened there. The only major senses that does not go through the thalamus, the olfactory, your sense of smell doesn't have to be screened. And there is some thought that that's probably a survival capability here. So here we are, we're going to go into here, it's going to go right into that olfactory cortex of the frontal lobe here. Axons from the olfactory neurons, cranial nerve number 1, cribriform plate of the olfactory bulb. This is the ethmoid bone right here. We're going to have those olfactory foramina right here. Guess I'm going to stop right now. Okay, you need to take a little break or something. You can go on out and then we'll pass out the tests and we'll get started on this exam and have you